I am Rafael Sugiura. I'm a solutions architect with AWS, and I do support Vanguard on their cloud journey and transformation. I have here with me today Donovan Stockton. Donovan is a platform owner at Vanguard for the Cloud Data as a Service, and he was kind enough to share his story and his perspective on the whole data migration start to AWS. So when we talk about data migration, it's such an amazing topic, an interesting topic, because it's where a lot of things start for most of our customers. They want to move data to AWS because that's how can really leverage the cloud benefits. They're going to leverage the benefits on the data side with things like elasticity and agility, but also everything that the data supports comes along. So if you think about things like microservices and analytics, machine learning, all of that depends on the data being accessible. So again, that's why we're so excited to be here today sharing this story with you. So let's get started. So when we talk about data migration, one very common pattern we see is just the standard lift and shift. And by lift and shift, we mean lift and shift of the data, but also lift and shift of the application itself. So let's take a look at this sample scenario here where you have a monolithic application running on-prem. You have some data stores on-prem, things like SQL databases, might be open or proprietary databases. You might have data storage with NFS volumes or tape for archival, all those standard stuff we have on our data centers, right? And if you're looking to move this monolithic application to AWS just in a lift and shift fashion on the application perspective, that's fine, right? Maybe sometimes that's the best way to start moving things to the cloud. And when we're doing that, you have to bring along with you the databases and data sets with you. So lift and shift works well in that scenario. AWS supports a lot of different tools to move the data. We support a lot of different databases on this lift and shift pattern on AWS. Again, that works, and that's possible with AWS. But what if you want to re-architect your application? What if you want to take full advantage of the cloud potential by using architectures like microservices, modern analytic platforms, or even things like machine learning and AI? If you're going that route, now lift and shift is not an option anymore. Because you need to make that data available to those microservices and your analytics and your machine learning and all new cool stuff. You need to support that with a modern data platform. You need a platform that supports the same agility that the microservice is going to provide, the scalability, the automation that entails this architecture. And that's what we're here to talk about today, right? How you can move legacy data and data sets to a modern data platform. So when we understand the why, right, we look at this and say, hey, OK, I understand why I would want to do that. The next question that comes with it is say, OK, but how? How can I magically transform those things? And there's a lot of ways to address this. We have a lot of white papers talking about this. But just for the sake of the discussion, I broke down this process in three big steps, three main basic steps. The first step is to identify your data requirement. And that's what I mean by data requirement is how much data do you have? What's your data access pattern? Is that something that needs to be real-time, low latency, or that's something that you access in a batch approach once a day in a very high volume? What's your data format in terms of schema, or are you using any kind of data files with specific formats like JSON, Parquet? So all of that matters when you're thinking. So you need to map that first. One thing that the data requirement is not, it's your current environment. A lot of times I talk to customers and they say, hey, I have a requirement to have a relational database on-prem because I have a relational database on, I need to have a relational database on AWS because I have a relational database on-prem. And that's not always true. So let's walk through that. So let's talk about the data requirements. You've probably saw that slide before. Some common use case or some common data requirements we see customers having is if your data have a very strong schema and it's relational by nature, right? That's one very common pattern. If you have requirements to have high throughput, low latency, and scalability, that's when we're talking about databases that have a key value approach. You might want to store your data in a JSON format, in a document format. That's another pattern. If you have very, very low if you require very, very low latency, you might consider in-memory types of databases. Graph databases help with things like data that have multiple relations. So think about, we always talk about social networks or even recommendation engines or things that tracks or works together with machine learning algorithms. Time series makes a lot of sense for if you have IoT generated data or data coming from market data, trading data. So the way we store, the way we query this type of data is totally different. That's why it makes sense to have time series. And if you have a ledger or you need to have a way to have store your data in a way that's immutable, you know the data was at that stage or at that point in time, you need the ledger for that. So again, you have to understand your data requirements. Maybe inside the same application, you have different requirements. It's just a mapping exercise you have to do inside your company. Once you're done with that mapping, then we go to step 2. And step 2 is all about mapping this data requirement to AWS services. You probably have heard here at reInvent or someone from AWS saying, pick the right tool for the job. Now is the time to do this. So when you talk about pick the right tool for the job, our life is easier, right? Since I've mapped my requirements, I know AWS offers all these different set of tools. So for some reason, I still need relational. You can pick things like Aurora, offers relational database in a managed fashion with very cool features like serverless deployments of Aurora or global tables with Aurora. If you need key value or document, you can look at things like DynamoDB that you can scale, or DocumentDB with MongoDB compatibility. And the list goes on and on and on. The message here is we have a very diverse set of purpose-built databases that you can select for your specific requirements. There's one specific database or data storage that's not listed here in this table, but I want to call it out. It's S3. You probably know about S3 by now, one of our first services. So in S3, you can store unstructured or semi-structured or even structured data using formats like JSON, CSV, and Parquet. And why does that matter if you talk about databases? Does that matter? Because now if you're storing that data on S3, and if you have tools like Athena that allows you to query that data directly on S3, now you can build a very strong foundation for your data lake requirements, for example, without thinking about specific databases per se. Right? So S3 with Athena and many other services can work together to provide you this foundation of the data lake, as I said. So please take that in consideration as well when selecting the services. So now I know my data requirements, and I know where my data is going because I selected the service. I understand my requirements, my services. The next step is to move the data. And to move the data, we go step 3, right? You're going to select the transfer tools and methods to move the data to AWS. And let's take the same approach. Let's think about the requirements first, and then which tools can fulfill those requirements later. So on the requirement side, you might have things like online data transfer requirements or offline data transfer requirement, meaning I just have a bulk of data that I need to move to AWS. It's more one point-in-time type of transfer. Or I might need hybrid storage. Let me give you some examples of those tools that fulfill those requirements. On the online data transfer example, you can have even more specific requirements. If you need to stream data to AWS, you can select things like Kinesis or Kinesis Firehose. If you just need to transfer files, maybe data sync is a better option. If your application is a legacy application that only talks SFTP, and we can't get rid of those applications, right? They're still there somewhere. That's why we offer services like SFTP as a managed service that you don't have to run any servers or provision anything. It's fully managed by AWS. But sometimes it's easier or more cost-effective or even faster to just physically ship the data to AWS. So that's what we call the offline data transfer. And that's where the products of the Snow family helps. You can use services like Snowball or Snowmobile. And what does that mean is that we're going to ship a purpose-built device to your environment. You connect to your network, you load your data on that device, and you ship that data back to AWS. With Snowmobile, you're going to park a semi-truck in your parking and connect to your network. If that makes sense, if you have petabytes or exabytes of data to move. But the idea is you just have that other option to do this offline data transfer. If you need hybrid storage, and what I mean by hybrid storage is to locally, on your data center, present the storage as through standard protocols like NFS or SMB, but having that storage backed by S3 automatically, so that gives the scalability and the cost effectiveness of S3, while still keeping compatibility with the older traditional systems. So for that, we have services like Storage Gateway. So it's just to understand that you have all these different options, and you can and should pick and choose the right tool for the job on the data transfer as well, in the same way you did for the database selection. So just a quick recap. You identify your data requirements, map those data requirements to AWS, and select the data to transfer the tools. Right? If you put that way, it's simpler. Let me walk you through a quick example just to make a point of what I'm talking about here. So in this example, very similar to my initial example, I have, let's say it's an e-commerce website. So in this e-commerce website, we have a monolithic application, and my e-commerce website have things, of course, like customer records, inventory of my products. Maybe I have here in the bottom the documentation. Those are the PDF files or the images for my web page, my e-commerce web page. Inventory purchase, of course. But sometimes we even store technical data like access logs for that server. Sometimes we put everything in the same database, right? It's not ideal, but it's not uncommon to find data architectures built exactly like that. And now you want to move that data to the microservice, to cloud, then you're going to re-architect that application. So you're going to use things like microservices, all the cool new things, right? So as I said before, lift and shift in that scenario is not an option anymore. So we can do things like breaking the data storage in different services. Maybe your customer record, it's relational by nature and have a very strong schema, and you need to connect to legacy ERP or CRM systems. So you should keep that in a relational database. You can pick Aurora for the customer records. For your inventory and purchase, you want the scalability and low latency because you have peak usage. So maybe DynamoDB is the best option. For your access logs, you don't need a database for that. You can store that unstructured data direct on S3 and query those with an analytics service. And you can also have things like S3 to store your documents in PDF in a much more cost-effective way than storing in a relational database. So now with that database distributed across all these different tools or platforms, you can use new tools to build your microservices, things like Fargate or Lambda or Athena, and plug those modern applications to your database. Your database is ready to support those services. And as I said, you need the step 3, right? You need to move the data. In this example, you can consider use things like database migration service to move the data from your legacy database to the AWS databases. Database migration services allows you to move data from database to database, but also from database to things like Redshift or even S3, Elasticsearch. If you're moving your files, again, you might consider data sync. And if you have a large backlog of data to move, maybe you can use Snowball for the initial transfer, and then later on you use data sync just for the incremental changes. So with all of that together, I think it's clear to see that, again, moving the data to AWS, it's a task that you guys are going through or are going to tackle soon, and to share the story on how Vanguard tackled that same journey, same challenge, and the experience they had, I invite here on stage Donovan Stockton. Thanks, everyone.
Thank you.
Thank you.
Thank you, Rafael,
Sure.
for introducing many of the concepts in the AWS data ecosystem. So today I'm going to talk about Vanguard, and I'm also going to talk about how we replicate data to the cloud. Now, as part of that story, I also have to talk about how we store data. So actually, if you attended the keynote today, you got a really good overview of Vanguard, but I'll just review a couple of things. Vanguard is strategically located between Wall Street and US East 1. It's a great company, 30 million investors, $5.6 trillion and climbing in assets under management. Many of you here today are likely clients of ours. And if you use our websites, you're likely using cloud data at AWS. So today what I'm going to do is go over the rationale for moving to the public cloud. So some of you have not committed yet to taking your data to the public cloud. I'll be reviewing with you many of the factors that led Vanguard to making that move forward. I'll also talk about the creation of a data platform engineering team. And there's some interesting things that I found out over a couple of years of working with people and the types of skills that are really needed for that to be successful. And then I'll also be talking about what's in a data platform. It's more than just saying, hey, here's a service from AWS, go bananas and go use this thing. There are a lot of things in a regulated industry, such as Vanguard, that you have to build in a platform. And a lot of those things require a pretty heavy engineering lift to make happen. I'll also be going over our database as a service. So there are parts of our business that don't need to replicate data. But if you are replicating data, you do have to store it in a database or another data platform. So first I'll be talking about database as a service and what we've done there, because new lines of our business are going directly to databases, and it's pretty successful. For those people who have data in our on-prem environment, and there's a lot of landlocked business logic on a mainframe, that's the primary source of data that we replicate to the cloud. I'll be going over many of the architecture patterns and the tools in our ecosystem and platform. And then I'll also be talking to you about a new service that we just released around moving files, and then I'll be sharing with you some of the lessons learned. Now, there are many more lessons that we've learned, but it's just a time issue of sharing all of those insights. And then we'll be talking about future direction. And this one, who knows, maybe in a year it's completely different than what I thought we would be working on. With the velocity of changes in the cloud, it's pretty amazing. So if you have not committed to moving to the cloud, I would suggest this is the slide that you want to take back and think about. This is really in the database context. We have really seen DevOps and moving to microservices in the cloud with managed database services was really a key enabler for us. The other thing is that you heard also earlier there was a bit of an attempt to go with a private cloud. You know, Vanguard's core competency is investments. AWS, their core competency is cloud. I'm willing to bet that they figured out a lot of things better than we could, and I'd rather just offload that processing to them. Now, in terms of capacity, you know, in an on-prem world, it's relatively fixed. It takes a really long time to scale out in a traditional on-prem environment. With cloud, it's code. I mean, it's really amazing how quickly you can scale out with these architectures. The other thing is that, and this is a really important one, with the managed services and fully managed services at AWS, what we've found is that many of the distinct roles that we used to have at Vanguard are now just things that people do on a DevOps team. So I'll be going over some of that later. And then also from a financial standpoint, you know, if you're buying software, you're making a big bet on that product. You're making a long-term bet. With cloud and pay by the drink, you can experiment, you can walk away from it, and you've only paid what you've used or forgotten to turn off. Okay, so program objectives. I was charged with creating read replicas up into the cloud of our enterprise data. We couldn't just simply pick up all that enterprise DB2 data and run all of our reads and writes up there. There's just too much landlocked business logic in COBOL. And to migrate all of that is a really big program. Now, the other thing is that we have new lines of business that are greenfield, cloud first. They went directly to databases, so we stood up a database as a service team. The other thing is DevOps, as I mentioned earlier. We wanted to collapse a lot of the things that people do in a job to stand up capabilities for applications, and what we found is that many of these services work really well for a DevOps team. The other thing is that Vanguard is global, and we're increasingly looking to move our compute and data closer to our global clients. So with cloud, and with specifically AWS's cloud, their global footprint is just amazing. The other thing is that, and this is the new service, we're starting to enhance how people move those on-prem batch-generated files up to the cloud. So in the past, they used to FTP them. Sure, they can use secure FTP, but we like the managed services of storage gateway and then increasingly data sync. And then also, we're looking to modernize how we hydrate the data lake. So in the past, those were files that were moved up to the cloud, and increasingly, as you see analytics and systems of engagement come closer and closer, there's a real-time data replication requirement. So we're starting to replicate data directly to the data lake. And then last but not least, and this was the toughest one, this is provide near real-time replication of enterprise DB2 data up to the cloud. And I'll be coming back to this one later. So the three main pillars of this program: cloud database as a service, and cloud and data replication as a service, and file transfer as a service. And we are part of the Chief Technology Office, so we enable these services for the enterprise. So here's a slide that was interesting that I could never have drawn up a couple years ago when I started to look at the team that I had and how we had to make some changes. So the first one I'll start off is the CAP theorem. It's one of the questions that I ask in a technical interview because I want to understand if people understand the concept of trade-offs. And this is really important. As you distribute data, you're really changing the architecture patterns that you've used in the past. And you want people to understand what those trade-offs are. The other strong Java and Python, that's the majority of the work that we do. You also want people who embrace the concept of innovation. This stuff is changing so rapidly. It's really hard to really deal with the velocity of these changes. Plus, you want people to take those concepts and apply them in creative ways to solve problems with these systems. The other is SRE. You want people who understand the concept that you need to monitor your environment, come up with creative ways of monitoring that, have very good concepts around telemetry, and understand that a service level, there's different levels of how you can view a service level. Is it apply to everyone, how well your application is performing, or only a subset? So that's where an SLI and SLO concept comes in. The other is you hire some data engineers, and are they willing to train people on how to use your platform? And this one, I would say, is very, very important. As you develop these systems, this information is not absorbed by your clients through osmosis. I mean, it takes some training, and sometimes it takes a little bit of collaboration. There are some use cases where we implemented what I thought was a pretty good architecture pattern. We provided a platform, and our clients had a hard time leveraging it in a production context. The other is continuous learning. You need people who are embracing the new technologies that continue to come. I always encourage my staff to listen to as many podcasts as they can, attend conferences, read blogs. There's just so much going on right now with cloud. It's really daunting, but it's also exciting. The other is just how you view people on the team. We used to have architects who couldn't code, and then we had tech leads who didn't want to think system design, and you really want to collapse those two into one role and view people as saying, hey, developing things are really how you ensure that a design is going to work. And then lastly, you need to know cloud. I mean, this is the AWS cloud. There's a lot to it, and you want proficiency there. If you have a staff that's not AWS expert, I would say, hey, it's worth investing in training and upskilling, and maybe with a little bit of staff augmentation. Okay, in terms of guiding principles for the program, we fully embrace the concept of database freedom. So we're moving off enterprise DB2, SQL Server as much as we can. We're targeting Oracle Exadata. We're moving that to Postgres and Dynamo. Cloud DBA and DevOps. So I talked about earlier the database and the roles for a DevOps team. One concept that we had was we had some DBAs and we said, hey, do we really need dedicated DBAs on a data platform engineering team? And the answer was no, because most of that's been offloaded to AWS. They're not doing the OS patching, they're not doing security patching, they're not doing the database upgrades. Those just become absorbed as part of that DevOps team. Wendy New is a consultant or principal consultant with AWS. She's got a great article on the role of the cloud DBA, and she does a really good job of focusing on how cloud DBAs, if they are a dedicated role, work purely in the optimization space. The other is fully managed is better than managed versus stand it up yourself. So there is a mix of things that are going to be in your platform. In some cases, it's a fully managed database service like Dynamo. It could be a managed service like Aurora. And if you're standing something up yourself, there are things that you're going to have to do, and we just prefer a fully managed database service. Fit-for-purpose database, I'm sure you've heard this like 1,000 times already, this conference, but we do believe in this concept. We came from a world where relational databases were pretty much the only thing that you ever got. And those databases try to do everything, and they didn't do everything very well. At AWS, as Raphael reviewed, there are so many different database architecture patterns. The other thing is automation over clicks. We do not want people in UIs, with rare exception. So if you manage a database and performance, you can leverage performance insights with RDS. That's been used pretty effectively by our DevOps teams. But for the most part, everything that we do is built around the concept of automation. And then the other thing, and this is what was a real pivot from the way we used to treat data, was it's engineered for lines of business. My team doesn't operate any of this stuff. All we do is we build a platform, we enable it, that's taken up in the lines of business accounts, and increasingly will become part of their micro accounts. So this is part of the self-provisioning aspect of this environment, and it was a real pivot from the way data used to be provisioned in the past. And then lastly, data infrastructure, don't confuse that with data management because they're different. Now in terms of what goes into that platform, we provide the builds so that the lines of business can take up these stacks into their environments. We cover functional gaps, and there are many functional gaps depending on your enterprise. Now like I said earlier, we're a regulated industry. There are a lot of audit things that we have to cover. There could be things with security, and you will have to cover those functional gaps. We've done that even with third-party products where we've covered gaps. The other thing is service enablement. So as AWS releases a new service, we go through a standardization process at Vanguard, and that means we have to go through regulatory steps, and there are many different compliance things that we have to do. The other thing is audit. So internal audit flags my team with certain risks, and we have to mitigate those risks, and I'll show you an example of what one of those risks are. Also, cost management. You will be spending a lot of money at AWS, but when you do, you've got to look at your value, and you have to really be careful about not over-provisioning your environment. The other is alerting and notification. Since we've shifted all of this to the lines of business for them to support, we had to provide a robust alerting and notifications architecture so that as they support the infrastructure that's been taken up into their environment, they have a way to support it. The other thing is architecture patterns. So I'll be walking through some of those, and I have a map that shows the dominant architecture patterns, and that is going to continue to grow. And then also tool selection. So as new services are available, there's new business requirements for new, like let's say a database, my team will allow the line of business to do the functional analysis. We want to make sure that it works for them. But then my team is really responsible for the technical, the strategic, and the financial analysis. And then lastly, we do vendor management. So if we have a product or we have a service from AWS, we will work with the teams to help influence their roadmaps. Okay, so first I'm going to go over database as a service. So this is a view of how getting a database in our on-prem environment looks. It takes about 14 to 28 days. There's just too many things that have to happen to get physical infrastructure in the way. And if I'm in the green box, that's a line of business. That's a pretty unpleasant way to get a database before you can begin your work. Now here's how you get a database at AWS, through our platform. So my team builds the CloudFormation templates. The lines of business put in the parts that they need to in order to create a full stack for their database. It gets deployed through CloudFormation. They get their database. They've stipulated whether they want read replicas and the machine instance class that they want for their database. And they get their database, and they're off and running in 4 to 5 minutes. Now here's an example of one of the exemplars where we lock down parts of that build so that the lines of business are not going to be unsuccessful. So you do have to lock certain things down as a platform team. Now here's an example of one of our platform services around alerting and notifications. We're looking for events. We route those through CloudWatch. We notify people. And we also route this through Snow so that there's an incident waiting to be managed by our tech ops team, because they are the ones with the production access. Okay, now here's an example of the things that we event on. Now, the thing that's really jump out at you is, why are there so many more of these events on the RDS Aurora side? And that's because it's a managed service. On the right side, DynamoDB, fully managed. Fewer things to event on. They're doing more for you. RDS and Aurora, you're also looking at physical characteristics of what's going on in that environment, whereas in Dynamo, it's more service related. And then here's our cost management architecture. My team gets access to dashboards about how the spend is going. The lines of business get their database or their dashboard view. And then my team says, hey, you know what? There are probably things people aren't going to take action on that are probably pretty low-hanging fruit, and I'm going to walk you through what we do in that respect. And regarding our strategy, we do want to, I think the key area here is we found that people typically over-provision in Kinesis. With respect to databases, they're generally pretty good about picking the right instance class. But for the most part, what we're seeing is that we've created a quarantine and eviction capability that's been working really well for us in our test and engineering sys levels, and we're going to look to apply that to production. So here's an example of stopping a database instance. Now in this case, we're looking for a database without a connection for 4 days. And if you guys, you can see here, since it's a 300 level, we'll look at some code. If there's no database connection in 4 days, we stop the instance. Now some of you may ask, why not do it after a day? And we picked 4 days because it takes a while for the application has to be recycled along with the database as it's brought back up. And then here, we're looking for low CPU utilization. Again, this is generally what we find in engineering and test. We wouldn't find this in production. Usually in the case of production, it's just they're slightly over-provisioned, and there's a little bit of a, there's a little bit more art than there is science with production. Now here's an example of audit capability. So internal audit came back and said, hey, you got to make sure there are no databases out there that weren't spun up with your build pipeline. So we wind up developing a rogue database detection capability. So we look to see if there's anything out there, even down to engineering. Like, we don't evaluate software or database technology unless it's gone through a pretty rigorous review process. Okay, now we're going to get into the really hard part, which is replication of data. So going back to our program objectives, I said I'd come back to near real-time CDC replication. We have 4 things that we really need to pay attention to. And one of those is handling initial loads. That's, before you start doing your replication of any of the changes, you have to actually do your full loads. And that's where a lot of the volume comes in. And that means a lot in the Kinesis world. As you create a number of shards, you bring in that load. We've seen a lot of teams initially size up for those initial loads, and then they forget that they have to size back down for replication loads. We needed to provide 1 to 2 seconds of latency, And then we also needed to reduce daytime MIPS. So it really was charged with moving as much of the data as we can up to the cloud so there's no reach back to DB2. And then we have a recovery time objective of 2 to 3 minutes, similar to how RDS works. And then our PO recovery point objective of 0 data loss. So since this is replication, and there's a slide at the end that I'll talk about around data integrity that really touches this one. So here's a typical day at Vanguard for just updates. We are a mainframe shop, market closes, accounts need to be updated with pricing. We kick off a nightly cycle. Now, in an ideal world, this would be a pretty flat line, but unfortunately it's not. So you have to size for these high watermarks. In the future, we are looking at auto-scaling and building that capability for our replication engine. But here in the case of 11 o'clock at night, we get 60 million updates, and we have to process those so that clients don't feel a lag in the updates. And so we have volume, we have a lot of these platform services. The first thing that you need to establish really for your platform is a build automation for the entire stack. You want a team to have everything that they need to start their data replication development. And that means they need Windows servers, they need EC2 instances, they need AMIs, they need ELBs, they need all the configuration that they need in order to start with data replication. So in this case, our main replication engine is Athena. This is the product that we use to replicate enterprise DB2 data on Z. That runs on Windows. And then we also have FSX for Windows for shared disk, and I'll be talking about why we're using that. We also store backups of this environment in S3. We use CloudWatch, again, to look for events that suggest that an environment's in trouble. So if action needs to be taken, it can be taken. Now, because we have this automated infrastructure environment, we also moved on to what's really, really important to us, and it's going back to that RTO and RPO concept. So we enhanced the Athena infrastructure that we have up in AWS, leveraging AWS technologies to deliver close to HA of 0 downtime. We're in the 2 to 3 minutes here. So we have a primary, we have a warm standby. The key here is that if there's an issue with the primary, we auto-fail over to that standby in a different AZ. So we're distributing where our compute is, and we have shared disk across those AZs so that the standby will know exactly where to pick up where the primary was, because you don't want to introduce data corruption. Now, here's another enhancement that we built into the platform. And this was really around developer efficiency. So as developers work on replication tasks in their engineering or test accounts, we needed an automated way for all of those tasks to be propagated into another sys level. So we built some utilities. We take out all the configuration parameters that are part of that development of the replication itself, and it eventually gets deployed and merged and updated with all the parameters that are in the updated or in the higher level sys level. And this has worked out pretty well. And then we use CloudWatch to look for any kind of events that came out of that whole propagation. And then we also notify the clients that there was a full success, or if there was a problem, they could go back and fix something. But this eliminates any of the manual work that's needed to work between different regions. Okay, now I'm going to talk about a map of how we help guide our clients, because there's so many different options, and we feel like this is increasingly going to become very important for clients to understand. With a fit-for-purpose world with so many different database options out there, and with different replication engines and different ways of moving your data, if you want to preserve your business logic, you stay relational, and there's nothing wrong with that. It's a matter of trade-offs. You won't get the scalability you will with NoSQL and Dynamo, but if you have battle-tested business logic and relational schemas, this is a pretty clean way of taking your enterprise data and replicating it to a relational database in RDS or Aurora. Now, if you have a 401k account with Vanguard, you're getting your balance information from Aurora. And they follow one of these patterns. They use Attunity, they replicate data to Aurora, and the microservice reads that. Your website shows you your balance information. Now, if you are a client who has low latency requirements, you take on a pretty big lift. There's a pretty big paradigm shift going from relational to NoSQL when you have replication of data. So we are using Attunity to replicate data to Kinesis, and then the lines of business write denormalization programs, and then they load that data into Dynamo. Now, if you have a strategy of saying, hey, I want to lower my MIPS, because MIPS, if you have a mainframe, you know MIPS can be an absolute killer with cost. We recommend that you use a combination of the first two columns there, and you implement a fan-out architecture. And I'll be walking through all of these. And then if you want to decrease the time that it takes to update your data lake, then you can use Attunity to replicate data directly to S3. And then we have some things that I can share with you about what we learned. And then if you want to simplify your coding effort to move files, and this goes down even to data corruption detection, you can use something like data sync to move extracted files, batch-generated files in your on-prem environment up to cloud. So here's the overview of how we replicate data from DB2 and SQL Server and Oracle up to the cloud. For relational, we go to RDS or we go to Aurora. And then the web service uses that. That's a pretty straight shot. And then if you want to go to Dynamo, you take Attunity, you replicate your data to Kinesis, you have your lambdas there to denormalize that data and load it into Dynamo, and then your web service will read that. Now, as I mentioned earlier, this is a paradigm shift, and it's really difficult because you're replicating relational data, third normal form data. When you replicate that data, and going back to one of those program objectives, replicate this in 1 to 2 second latency range, we're trying to move data as fast as we can. So Attunity will actually apply batches of these changes to Kinesis. Sometimes some of the members or messages need to be reapplied in another micro batch. Well, when that happens, some of our transactions involve many different elements to it. So if you open an account, you got to pick your stocks, you got to tell us who you are, you got to tell us about your beneficiaries. So until all those members of that transaction are received, you really don't want to process that transaction. So at this point, we were very happy that the vendor that we have for replication, Attunity, they built for us a unit of work capability. So this is metadata that tells us whether we've received all the members of a transaction. And I'll be showing you what that message looks like in a second. Now, until all those members of that transaction are received, we park them. And then once all the members are received, then we take them out of a park status and they get processed and then updated to Dynamo. So here's a look at a Kinesis message. The first outline is the payload business data. This is the data that you want to update to Dynamo. Second is the CRUD activity. What do you need to do with this data? And then last but not least is the unit of work. This tells us that this is the third member of that set, and it tells us this is the last member of that set. If it said true, then we know that there are more members coming in. We don't process until we see that. Now, here's an example of that fan-out architecture that I mentioned, and this is an interesting slide because we have two fan-out patterns going on here. So with Attunity, you can read once, write twice, and that's a real advantage because, as I was mentioning earlier, those mainframe MIPS, if you have 5 teams reading the same data, that's going to be 5x cost. So what we're really doing is encouraging these teams to read once, write multiple times, and consume multiple times. So in this case, the first fan-out architecture pattern is Attunity itself. So it's writing out for Kinesis, and it's writing out to our relational data. So if this is account data, it can be written out to Kinesis, and then Kinesis becomes the second fan-out pattern here. So you can consume a message multiple times. You can store that message for up to a day, and in this case, we're using it for our microservices, and we can also use it for our big data hydration. And then here's an example of how we're starting to modernize data lake hydration. So again, I think increasingly the data lake architecture pattern, sort of like the first generation of just moving batch files up to the data lake, I think those are going to, they're going to still have their place, but increasingly people are going to want the same latency with the data lake that they're getting out of their systems of engagement databases. So in this case, we replicate data either with DMS or with Athena to S3. Now, this was the architecture pattern that I mentioned earlier. For us, this was a pretty straightforward architecture pattern to follow. For the lines of business, they looked at this and they said, how do I do transaction replay in S3? And that was a really difficult thing for them to grapple with. So my team created some exemplars. We wrote up some blogs on how to do it, and it still didn't resonate with them. So as I mentioned earlier, sometimes you just have to engage your clients and get them to really understand how to work with data. This is low-level data development at this point. But this is now starting to take off as a really good way to get your data up to the data lake in real time. Okay, now this is a slide that I never thought I would be signing up for. I just thought this was something that was going to be the domain of the lines of business because I don't operate the data, I don't know the data. However, I was challenged on numerous times, and it was really hard to prove a discounted negative. I couldn't prove to them that I wasn't introducing data quality problems. So there are some things that you need to understand when you work with replication with your on-prem environment up to the cloud. You're spanning physical storage. So you don't have physical data detection capabilities available to you. So you have to go with logical checks. And this is when you start moving up the stack, and this starts to get a little bit more difficult. And this is why I thought this should be something that the lines of business would do. But this is a lot of responsibility for them. And so they're doing a lot already by taking up the environment. And the other thing is that I thought with our alerting and notifications about this system being available would suffice, and that just wasn't the case. So we landed on a level 1, and I'm going to show you what that level 1 looks like. But essentially, we're looking at stats, database stats, and we're comparing them to what we get in Kinesis to make sure that we don't have count mismatches. What we're going to be taking on for next year is more of a higher level logical data detection, and what we're going to be doing there is looking at account totals and providing but we're worried that this thing might be as big as replication itself. So we're not sure where we're going to land on with that. So here's the architecture for that level 1 data validation. We take DB2 stats out of DB2, we replicate them. We replicate them into Kinesis. We are replicating the business data. We have lambdas to move that data into Dynamo. We do comparisons. When we start to identify a problem, we then notify the lines of business that there's a data corruption issue. And then the last service, and this one I think is going to be as big as any of the services that we've released, is file transfer as a service. So this is modernizing the way we move files up to AWS storage gateway, great for ad hoc file movement up to the cloud. We've got many clients using that. The one that we're really excited about is data sync. And we're really excited about that because we have some use cases coming where we're going to be taking system and application logs across the entire on-prem environment and moving them up to cloud for forensics. And it's just something that was not possible in an on-prem world. So this one is really going to be part of that fulfillment of the cloud value proposition. Now here's the adoption of our platform. So the blue line represents database as a service. As you can see, Postgres and Aurora have been pretty well received, and the orange line here represents our data replication adoption. Now the key here is that our vendor for replication, that Athena, they delivered log streaming for us. So In the same way that Aurora works with log streaming with replication across its storage, they enabled a log streaming capability for us, which really saved us on MIPS. And we needed to save on MIPS because MIPS are one of those things where, yeah, you can pay a lot of money, but you also reach a point where you've reached a saturation point. You have to buy a new processor. That's a couple $1 million right there, and then you have to pay for all the licensing that's based off compute off that mainframe. So it could wind up becoming $4 million when you reach a certain threshold. So this log streaming capability was really important for us to handle the high volume of data that we're replicating to the cloud. Now, here's our database as a service adoption. And what's interesting here is you can see it's spread across all of our lines of business. So many, many parts of Vanguard are using cloud database as a service. And we're really happy about that. Now, our replication picture is, it's limited to fewer of our lines of business because fewer of those businesses are tied to that mainframe. But as you can see, the adoption's really happening. So in closing, the lessons learned, the innovation cycle at AWS is really exciting. At times it feels daunting. I can tell you roadmaps and having visibility into those roadmaps, do what you can. There was a time earlier this year where my team released a capability for auto scaling of RDS. And on the day that we were going to prod, AWS released that service. So this is a case where you have to be very careful about the velocity of their roadmap and just try to engage as many people as you can at AWS, work through your TAMs, work through your solution architects to kind of get an idea of what's coming. But that innovation cycle is happening really fast. And the last thing on that is it's sort of like the AWS roadmap and innovation cycle is like 7 to 1. It's almost like dog years to human years. 1 year of their roadmap is equivalent to 7 years of any vendor I've worked with. Cost management, very, very important. Just for the cloud data program, I think I spent more money on my first home than I spent a month on this program, but it's good value. So I will say that we do come away from it feeling that way. And then vendor roadmaps can be influenced. So you saw a couple of capabilities that Athena delivered for us, unit of work, log streaming. With AWS, it's said that 90% of their roadmap is influenced by what clients are asking for. So if there is a capability that's really important to you, put in a service request, and I think they do a pretty good job of entertaining your use case. The other is ensure that your security management teams and their strategies are really aligned with yours. You don't want mission misalignment there. So a lot of the security tools that worked, especially with provisioning of credentials and authorization models, the software that worked in the on-prem world doesn't always work in the cloud. So you got to make sure that they're going with you if you decide to go to the cloud, because that could really slow you down. And then the need to upskill for the cloud is really, really important. The one thing I'll mention about that too is it's continuous. You have to always focus on learning with the cloud. And then the headcount to enable services and to build services around our fully managed database services and any of the managed services for that matter were really a fraction of the headcount. Standing things up, you might look at a team that's like 8 to 10 people. Standing up a team for a fully managed database service, it's less than a headcount. And then last but not least, just continue to watch those MIPS if you have a mainframe shop. I mean, those MIPS really can be a hidden cost. Okay, and then for the future, we are looking to increasingly add more and more serverless to our architecture. We already have a lot of serverless components in that architecture. Today, the majority of what we replicate up to the cloud is for read-only. In the future, we will support a write architecture. So we'll allow those clients to also write transactions back to DB2, and we're working on some interesting architectures there. Data virtualization, you don't want to always move the data. So although I've talked about replicating all this data and moving all this data, we also want to look in the way of how can we start to virtualize data. I think some of the things that AWS is doing with Athena around virtualization and federation is actually pretty promising. And then it's also, moving on, we're looking to integrate not only the stack within certain capabilities, but we want to cross-integrate these stacks. So I would love a time when replication, database as a service is fully integrated with the application development stack. And then also, we're looking for test data management to work for us up in the cloud. So many of your clients are going to do heavy testing in the cloud. In the absence of data masking, it's pretty hard, so we ourselves are working through what's the best way to mask this production cloud data down for test purposes. And then we're also looking to go full bore on multi-region. So we are, and I'll give you a heads up on that, we're going to replicate in one region and have AWS do the data platform replication cross-region. That's just something we don't want to take on. We initially looked at that, and there was just too much complexity. And as I mentioned earlier, cloud is the core competency of AWS, so it's better to leverage that where you can. And then last, the 4 databases that we're really excited about possibly bringing on very soon. Redshift, and I'm really excited about Aqua, and Neptune, and QLDB. I think QLDB is really interesting database. I think we have some really interesting cases there for some of our trading systems, and also for some of the, if you want to have true good security with your database, have an immutable data store is absolutely the way to go. And then DocumentDB. So with that, we want to thank you for coming today. Please fill out the survey. We can take questions here or outside? Okay, we'll take questions outside. Thank you very much for coming today.